Hello. Let's recall some properties of arithmetic and geometric sequence. So, first of all, we need to remember how to prove that a sequence is to prove that UN is an arithmetic sequence. For example, arithmetic sequence, and how to prove that a sequence UN is geometric. Okay, now to prove that the sequence arithmetic, this means that this sequence have along all its terms a fixed difference between every two consecutive terms. That is, we say un plus 1 minus un equals to d. What do we call d? D is called the common difference. Now, on the other hand, here we have to prove that the ratio of any two terms, un plus 1 divided by the preceding term un, is equal to a constant number, let's say r, as r is referred to common ratio. Okay. Now, what about if we want to prove that a sequence, this is the element of the sequence, let's say the common difference. Now, what about to prove that sequence is not? So to prove un is not arithmetic or not geometric. Concerning not arithmetic, here we are talking about one example. That is one special case. Concerning one special case, we can rely on example to prove that this case is not true. To prove that the sequence is not arithmetic, it's enough to prove that u2, for example, minus u1 is different than, for example, u7 minus u6 or u3 minus u2 or u1 minus u0. So it's enough to have three terms of the sequence to prove that the difference is not the same. So u2 minus u1 is different than u1 minus u0. Now, what about in case of geometric sequence? The same, but concerning the ratios. u2 divided by u1 is different than u1 divided by u0. Now, what about the general term of each kind of these sequences? Say the general term. As we have seen before, the general term of an arithmetic sequence is un equal u0 plus nd, or it's un if the first term is u1, we say that the number of differences will be decreased by 1, so n minus 1d. Or more generalized formula, we say un equal up, and from p to n, we have n minus p differences. On the other side, concerning the geometric rule, the geometric sequence, the general term is un equals, sorry, un is equal to u0 times r to the power n. un, if the first term is u1, we say r to the power n minus 1. And if the first term is up, then we multiply by r to the power n minus p. This is concerning the general term. Now, what about the sum of n terms of geometric sequence? Well, we have to distinguish whether this sum starts with u0 or u1. First of all, let's talk about the sum if it starts from u1 s equals to u1 plus u2 plus etc. plus un. And in the other case, we'll study the case if it starts from u0. Okay. Concerning the arithmetic sequence, the rule indicates we have the number of terms, which is in the first case n terms from 1 to n. We have n terms. We divide n by 2 and then multiply by the sum of the first and the last term. We do the same in the second case also, the same rule, but here the number of terms will be different. From 0 to n, we have a term more than the n terms. That is, we have n plus 1 terms divided by 2 into the first term plus the last term. In the case of geometric sequence, the sum will be the first term u1 multiplied by 1 minus r to the power n divided by 1 minus r. And if we use u0 in the second case, then we have one more difference, one more ratio, sorry, n plus 1 over 1 minus r. So these are the rules covering the arithmetic and the geometric sequence. Now, there is an important property that we can talk about it concerning the arithmetic and the geometric sequence, which indicates that if we have three consecutive terms, if A, B, C are three consecutive terms of an arithmetic sequence, in case of an arithmetic sequence, then we can easily say that the midterm is the midpoint of the ending parts. That is, B is A plus C divided by 2, or in other words, we can say that A plus C is double of B, or A plus C is B plus B. And concerning the geometric sequence, then A times C is equal to B times B, or in other words, we say that AC is equal to B squared. Sorry, this must be in green. So AC is equal to B squared. Okay, now let's do a small application concerning these rules. Consider a sequence un defined by un plus 1 recursive definition. What do we mean by recursive definition? We have a relation between every term in the sequence with the term preceding it. That is un plus 1 with respect, for example, to un. Let's say it's equal to 3un minus 2, where u0 is equal, for example, 2. Now here, this is a recursive definition. I have a relation between un and the following term, un plus 1. Now, let's take a first question. Part 1, calculate u1 and u2. Well, answering this question, u1 is one of the terms of the sequence. And here is the general rule of the sequence. Here we have un plus 1 is equal to 3un minus 2. u1 depends on the term preceding it, which is u0. Exactly. So u1 depends on u0. How do we obtain u1 from u0? There is a rule that covers all the terms of the sequence. Every term is equal to 3 times the preceding term minus 2. So here we say u1 is 3 times u0 minus 2, which is 3 times 2 minus 2. I get 6 minus 2, which is equal to 4. Now, what about the second term, u2? Also, it is 3 times what? The preceding term, which is u1. 3 times u1 minus 2, I get 3 times. the obtained number 4, you get 12 minus 2, which is equal to 10. Now, in the second part, I'll ask you to show that or verify that the sequence, this given sequence UN, is neither an arithmetic sequence nor a geometric sequence. How do we prove this one? In fact, to prove not, let's go back. To prove not, here, to prove not, we have to take an example. Take at least 3 terms and prove that this is not true. Here we have 3 terms. I have u0 is equal to 2. I have u1 is equal to 4. I have u2 is equal to 10. Okay, testing the differences, u1 minus u0 is 4 minus 2. u2 minus u1 is 10 minus 4. As u1 minus u0 is different than u2 minus u1, consequently we say un is not arithmetic. Now, is it geometric? Let's check first if it works. I have here u1 divided by u0 is equal to 2. u2 divided by u1, 10 divided by 4, it's 2.5. As these ratios are different, what does this mean? This means that un is not geometric. So here we have a sequence that is neither arithmetic nor geometric. How to get what? How to get the long terms, how to get the far terms. If I want to get, for example, u20, I need to find all the terms preceding it. If I want to find u100, I want to find also then all the terms preceding it. No, there is a solution. What is the solution? In the question, we give you a new sequence. It's called a helping sequence. For example, here, let's say we have a new sequence, Vn. Consider this is part 3. Consider a sequence Vn, which is equal to un minus 1. Okay. Now, we want to prove that prove that or show that, or before showing this, let's calculate, for example, calculate V0, V1, and V2. Now, in this question, I have a new sequence called Vn. What's the difference between Vn and un? Vn is 1 less than un. That is, every term of the sequence V is 1 less than the term of u. So if we go back to u, we know that the first 3 terms of u are 2, 4, and 10. 2, 4, and 10. So simply, we subtract 1. Here we get 1, 3, and 9. So if these are u0, u1, u2, here we get v0, v1, v2. And if you look at the first 3 terms of v, it seems as a geometric progression. Let's go back to the exercise. Now, let's calculate v0. As mentioned here, we say v0 is equal to u0 minus 1. That is 3 minus 1, which is equal to 2. The same thing we do for v1, which is equal to what? u1 minus 1, which is 4 minus 1, 3. And finally, v2 is u2 minus 1, that is 10 minus 1, which is 9. What's wrong here? Sorry. This one is 3 minus 2, which is 1. Okay? So this is the first term, u0 was 2, exactly. So u0 was 2 and not 3. I get here 2 minus 1, which is 1. Now here we get the first 3 terms. We go to part B. In part B, I'll ask you to show that Vn is a geometric sequence. Don't ever try to do this. Some students do this. Look, they say that the terms are V0, V1, V2, 1, 3, 9. We say V1 divided by V0 is 3 divided by 1, and V2 divided by V1 is 9 divided by 3. So V1 over V0 is equal to V2 over V1, and this implies nothing. We can say that depending on this example, the sequence Vn is geometric. I can't rely on an example to prove something true for all n. Probably the next term, which is V3, probably it will be 10, for example. I can't use this example. So to prove geometric, there is a rule. Where's the rule of proving geometric? Where's the proof? This one. This is the rule of proving sequence geometric. Un plus 1 divided by un is equal to r. This if the sequence is un. Here I have to prove vn. So what is that required to prove? Required to prove that vn plus 1 divided by vn is equal to a constant ratio r. Now vn plus 1 divided by vn is equal to vn plus 1 divided by vn. Look, first of all, I have vn here. So I write it down here, un minus 1. Then I repeat it above, but with only one difference. Instead of n, I put n plus 1. Then this un plus 1 will appear in the given of the exercise here. So I'll take it and write it there. I get it was 3un minus 2. And then continue. Minus 1 divided by un minus 1. I'll get 3un minus 3 divided by un minus 1. Take 3 as a common factor and then simplify as un is different from 1. Then we get 3, which is the common ratio. We say therefore Vn is a geometric sequence of common ratio r equal to 3. Okay, what do we conclude now? When the sequence is geometric, I can apply the rule of the general term. Back here, okay? Back here we have the rule of the general term. What is the rule of the general term of a geometric sequence? It's un times un equals u0 times r to the power n, this one. This is the rule of the general term. So we use it for v because u is not geometric. The sequence which is geometric is v. This is geometric. Now this will be the new question, part C. I'll ask you to express Vn in terms of n. Well, simply we say that Vn is geometric. Vn is geometric, which means that Vn plus 1, sorry, which means that Vn is equal to V0. This is the rule of general term of geometric sequence. V0 times r to the power n. V0 was 1 times r, which was 3 to the power n. This means 3 to the power n. This is the final answer of Vn. So here we expressed Vn in terms of n. The new part now we say deduce un in terms of n. Now, UN is neither arithmetic nor geometric. I can't apply the general rule. But in fact, I have a relation between Vn and Un. I know that Vn is Un minus 1, which means that Un is Vn plus 1. And consequently, this means that Un is equal to 3 to the power n plus 1. This is Un, and you can check the result. You can, for example, find U0. It will be 3 power 0, 1 plus 1, 2. And this was the given. You can find U1, 3 power 1 plus 1, it's 4. You can find U2, 3 power 2, 9 plus 1, 10. Yes, we calculate it. You can find U3. What about if I told you to find, for example, this is part 4, find U10. What do you do to find U10? Simply you say that U10 is equal to 3 to the power 10 plus 1, and you can use the calculator to find this value. Also, I would ask you to find limit as n tends to infinity of Un, for example. You say limit of Un as n tends to plus infinity is 3 to the power plus infinity, which is plus infinity. Thank you.